Hello YouTube, this is JD. Today we're going to talk about the Barbosa Leal device from Brazil. I built it right here from the schematics I found on overunity.com forums. You can go over there, overunity.com, and do a search for Barbosa Leal, and you find several schematics, also back reverse schematics. There was some guy on the forums that had a Captor device in his hands and reversed engineered it. So this is built by the reversed engineered schematic we found. So you got a secondary coil, the big black wire, black cable. This is the input. The input is coming from there. There's a breaker, a 16 amp breaker, a power meter that goes over there to the primary coil inputs. This is the phase. Let me see. Now this is the phase and the neutral. So this is the input, the phase and neutral. I'm going to show you in a minute. And as you can see in the schematics, the phase is connected to the secondary coil, which is a closed loop, by the way. The trick is, Barbosa tells us that you capture electrons from the ground. This is the ground wire. I'll show you in a minute on the switch panel. I had to make a separate group, otherwise it didn't work. There's an issue with the RCD switch, the current device. What was it? Residual current device. It doesn't matter. Anyway, that device tripped all the time, so I had to make a bypass. So we can have a closer look at the device. I got a load up here. I use a blow dryer as the load. So it's a 1600 watt, 1600 watt blow dryer. And yes, it does work. At first sight, let me show you. Let me turn on the system. Can you see this on camera? Can you see the number? It shows 19.4 watts in idle. So that's the idle wattage at the input. Okay, let's have a look at what's going on in here. There's a lot of current going on right now in the secondary. I got a clamp ammeter, 0. Let's see what's going on here. So this is the current right now in the secondary. It's about 90. Well, it fluctuates a little, 95, 96. I hope we can capture that on camera. Do we have it?
No.
Okay, let me turn this over. Is that better?
Yeah.
So we got 100 amps here.
Yes.
You got it? Good.
Yes.
Alrighty. So let me show you the voltage as well. So on the input we got phase and neutral. We got 232 volts on the phase and the neutral. And here comes the kicker, phase to ground. Let me see, where's phase to ground? This is ground. Is also, show the meter again, 232 volts. So that's exactly the same. So phase to neutral, 232, and phase to ground, same voltage. So that shows us we got a correct ground. We got 100 amps in the secondary going on, 20 watts in the primary, and we're gonna hook up a load. Let's see what happens. Yes, it works. Nothing changes. Secondary current is still 100 volts. The input wattage is 20 watts. Don't go to the close. Still 20 watts. Okay, we got it. we got some heat from the blow dryer, so we use real power here. But the voltage dropped. Let me show you. The secondary voltage from the output, this one, output, input. The voltage dropped to 142 volts. That means we got some resistance to the earth. That might be the reason why the voltage dropped, but I'd like to have your comments on that, please. So show the whole picture we got now. So we have a voltage drop, but that's not the main important thing. We're going to change one thing. We're going to use the power meter in the output now. So give me a second. Now this is going to be interesting because we are consuming 400 watts, 387. That could mean we got 20 times over unity. But do we have over unity? Well, let's see if we got over unity. 20 watts input, 400 watts output. Here it comes. The input current is 0 on neutral. This is the neutral. But we got hold on. We got 2.3 amps on the face, and let's do the neutral again. Still 0. So 0 on neutral and about 2.4 on the face. Let's see what's going on the output to the blow dryer. So we got about the same amperage. We got about the same amperage in the output wire as well. So this is the ground wire. About 2.2 amps, 2.0 amps. The meter is 200 amps, so this is very inaccurate, but you get the idea. 2 amps going on, so we got about the same current in the input as the output. So from this point on, draw your own conclusions. Thanks for watching, guys.